Namaste friends, I welcome all of you in this today's session. So today we are going to discuss what is meant by spectroscopy, then different terms involved in spectroscopy such as electromagnetic radiation, characteristics of electromagnetic radiations, then monochromator, prism, diffraction gratings, okay, and how the spectroscopy is used in the chemistry. So that things we are going to discuss in this spectroscopy chapter. So let us discuss our concepts. Now what is a spectroscopy? Spectroscopy is a branch of chemistry which deals with study of interaction between electromagnetic radiation and matter. During such interaction, energy is either absorbed or emitted by the atoms or molecule present in the sample in the form of the energy, in the form of small energy packets called as the quanta. Okay, now for example, how the spectroscopy works. So the electromagnetic radiation from a hot source is emitted, and this electromagnetic radiation is nothing but the electric and magnetic field, okay, traveling perpendicular to each other in a space. Okay, so this EMR, electromagnetic radiation, strikes on the sample, and then either sample will absorb the electromagnetic radiation or it will transmit the electromagnetic radiation. Okay, हा sample काय करतो? Okay, so when the electromagnetic radiation strike on the sample, then two type of phenomena takes place, either absorption of electromagnetic radiation and emission of the electromagnetic radiation. So the radiation emitted from sample is measured with the help of detector, and this detector analyzes the absorbed or emitted radiation, and it is shown on the monitor. Okay, and from this we can determine, we can do the quantitative as well as qualitative estimation of our sample. Okay, now let us see each concept in detail. Now what is meant by the electromagnetic radiations? So here this is the electromagnetic radiation, and the red line shows the magnetic field and blue line shows the electric fields. So here you can notice that both the electric and magnetic field are perpendicular to the each other. Okay, they are traveling in space with time. So what is the electromagnetic radiation? Let us define it. It is a simple harmonic wave propagated from source and traveling in a space in straight line with time. It is a simple harmonic wave propagated from source and traveling in a space in straight line with time is called as electromagnetic radiation. In electromagnetic radiation, so here henceforth we will call electromagnetic radiation as EMR. The electric field and magnetic field both are perpendicular to each other. You can notice here. So each electromagnetic radiation is associated with the electric and magnetic field, and both these fields are perpendicular to the each other. Okay, so now this electromagnetic radiation is emitted from any source, and this is the basic diagram of spectrophotometer. Okay, schematic diagram of spectrophotometer. What happens in this diagram? You can notice that the light EMR is emitted from the source, and the light is focused with the help of collimator lens. This is the lens. Okay, here it focuses the intensity of light. Then this light passes through the prism. Now what is the role of prism? Prism acts as a monochromator. Monochromator means it converts this polychromatic light into the monochromatic light. Sorry, prism disperses the light, and this light is fall on this wavelength selector, or it is called as the monochromator. Here we can select the required intensity of the light, and this light falls on the sample, and this sample either absorb the light or emit the light, and the transmitted radiation is measured on the detector. So we will see each component in detail in next lectures. Okay, so now what are the characteristics associated with the electromagnetic radiation? So first characteristic of electromagnetic radiation is the wavelength. So what is the wavelength? It is the distance between two successive maxima or minima on electromagnetic wave. So this is the electromagnetic wave, and distance between two this crust, it is called as crust, sorry, it is called a trough or maxima. दोन मॅक्झिमा मधलं अंतर किंवा बॉटम साइडला दोन मिनिमा मधलं अंतर म्हणजे वेवलेंथ. ओके, डिस्टन्स बिटवीन टू ट्रफ्स और डिस्टन्स बिटवीन टू क्रस्ट मॅक्झिमा और ट्रफला मॅक्झिमा म्हणायचं आणि क्रस्टला मिनिमा म्हणायचं. डिस्टन्स बिटवीन टू मॅक्झिमा इज कॉल्ड एज वेवलेंथ अँड डिस्टन्स बिटवीन टू क्रस्ट और मिनिमा इज ऑल्सो कॉल्ड एज दी वेवलेंथ. सो it is the distance between two successive maxima or minima on electromagnetic wave is called as the wavelength. Now it is shown by the symbol lambda. It is shown by the symbol lambda. Now what are the units? Just give me 1 second. Yes, so unit wavelength is generally expressed in distance such as centimeter, meter, etc. Okay, now 1 meter is equal to 100 centimeter. 1 meter is equal to 100 centimeter. Meter symbol is m, centimeter symbol is cm. So in 10 power we can write as 10 raised to 2 centimeter. Second unit, 1 micron. Okay, symbol is mu, is equal to 10 raised to minus 4 centimeter equal to 10 raised to minus 6 meter. Next, 1 nanometer is equal to 10 raised to minus 9 meter. These are the different conversions we will require in during solving a problem. 1 angstrom, this is the famous unit of the wavelength. So generally wavelength is expressed in nanometer or angstrom units. So 1 angstrom, look at the symbol A0, which is equal to 10 raised to minus 10 meter. Next, 1 nanometer is equal to 10 angstrom, which is equal to 10 raised to minus 3 micron, which is equal to 1 millimicron. Okay, so these are the different ways of expressing wavelength in different units. Now second characteristic of electromagnetic radiation is the frequency. So what is frequency? The number of complete wavelength unit passing through a given point per unit time is called as frequency of radiation. Okay, let us read together. The number of complete wavelength units passing through a given point per unit time is called as frequency of radiation. Now you can notice here, so wavelength, when wavelength is increases, the frequency decreases. So less number of wavelength, okay, passes through a given point if wavelength is more. If I reduce the wavelength, then what will happen? The number of wavelength increases. Okay, if I reduce more wavelength, then number of wavelength increases passing through a given point per unit time. So this is called as frequency. Now what is the unit of frequency? So generally it is shown by the symbol mu. It is expressed in cycle per second or hertz. 1 hertz is always equal to 1 cycle per second. 1 hertz is always equal to 1 cycle per second. Now next characteristic of electromagnetic radiation is wave number. So what is wave number? The number of waves per centimeter in vacuum is called as wave number, or simple definition is reciprocal of wavelength is called as wave number. Okay, so number of waves per centimeter in vacuum is called as wave number. Means what? Look at, this is the 1 centimeter distance in the vacuum, and you can calculate how many waves are present in this 1 centimeter distance. एका सेंटीमीटर मध्ये किती wavelength आहेत? Number of waves per centimeter is called as the wave number. So you can notice here that as wavelength go on decreasing, number of waves in 1 centimeter increases. So the less wavelength, more will be the wave number. More wavelength, less will be the wave number, and less wavelength, more will be the wave number. So this is the inverse relation between wave number and wavelength. Unit of wave number is centimeter inverse, or generally wave number is expressed in centimeter inverse or Kaisar unit. Okay, Kaisar symbol is capital K. So 1 Kaisar unit is equal to 1 centimeter inverse. Next, what is the relationship between frequency, wave number and wavelength? The product of wavelength, frequency is equal to the velocity of wave in the medium. Okay, means the wavelength into frequency is always equal to the velocity of light in the vacuum. The velocity of light in vacuum is shown by symbol small c, frequency mu, and wavelength lambda. Therefore, lambda into v is equal to c, where c stands for the velocity of light, and this velocity of light is equal to 3 into 10 raised to 10 centimeter per second. Okay, just rearrange this equation. 1 upon lambda is equal to mu upon c, and 1 upon lambda is nothing but the wave number. So wave number is equal to 1 upon lambda, which is equal to mu upon c, frequency upon velocity of light, that we will need in the problem. So let us discuss one problem on it. Calculate the frequency and wave number associated with the radiation of wavelength 400 millimicron. Okay, 400 millimicron. So frequency आणि वेव्ह नंबर या दोन गोष्टी काढायला विचारल्या आहेत आणि दिलं काय, वेवलेंथ दिली आहे. सो राईट डाऊन गिवन wavelength is given lambda is equal to 400 millimicron. Milli means 10 raised to minus 3 and this micron means 10 raised to minus 4 centimeter. So therefore lambda is equal to 400 into 10 raised to minus 7 centimeter. Now we know the relationship between frequency, wavelength and velocity of light. The relation is equal to lambda into v is equal to c, where velocity of light is equal to 3 into 10 raised to 10 centimeter per second. Now what will the frequency value? Frequency mu is equal to c upon lambda. Just put the value of c, put the value of lambda, simplify this equation, then we get the value of frequency is 7.5 into 10 raised to 14 per second. Next, the value of wave number is nothing but reciprocal of the wavelength. Just put the value of lambda here and simplify, then we get value of wave number as 25,000 centimeter inverse. Okay. So in next lecture we will see the basic terminologies used in the spectroscopy, such as radiant energy, radiant power, transmittance, absorbance, absorptivity, molar absorptivity and path length. So thank you for watching this session.